So 3.2, law of cosines. We have a standard form. I'm going to write three equations for the law of cosines for an oblique triangle. A squared is equal to b squared plus c squared. So far it's like the Pythagorean theorem, but since this is not a right triangle, we'll continue minus 2bc cosine of angle A. And in a similar way, we write the other two equations. B squared equals a squared plus c squared minus 2ac cosine of angle B. And finally, c squared is equal to a squared plus b squared minus 2ab cosine of angle C. If you solve for cosine of the angle, then you have alternate form. So alternate form, which you don't have to remember the alternate form if you know the standard form. You can always solve for cosine of the angle. So cosine of angle A, if you solve for it, will be b squared plus c squared minus a squared over 2bc. And cosine of angle B is a squared plus c squared minus b squared over 2ac. And finally, cosine of angle C is a squared plus b squared minus c squared over 2ab. Again, remember these standard forms, so memorize it. And if you know those three, you can always write the alternative form, the alternate form. So example, we're going to look at the case where three sides are given. So three sides of a triangle are given. We call this case side, 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 just from trigonometry. Side, 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 three sides are given. Find the three angles. All right, we're drawing a triangle. Again, it's an oblique triangle. And the given sides are side A is 8 feet. Side B is 19 feet. And side C is 14 feet. So a good idea is to start with the angle opposite of the longest side. So that's angle C. We're going to start with finding angle C. In case angle C is obtuse, we want to know that right away. Actually, on further note, the biggest angle is angle B, not C. We're going to try to find angle B. So cosine of angle B, if you look at the alternate form, that is a squared plus c squared minus b squared over 2ac. And we substitute. So that is 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14. And that is approximately negative 0.45. Okay, my picture is not drawn to scale. Angle B has to be obtuse. So I'm going to fix it. I'm going to redraw this triangle again. So now angle B is the obtuse. Okay, so angle B here, C here, angle A here. C is 14 feet, B is 19 feet, the longest side, and A is 8 feet. All right, so we had cosine of B equals negative 0.45. So cosine of the angle B is negative. What that means is angle B is obtuse. We know that if cosine is negative, the angle is in the second quadrant, so that's obtuse angle. So use your calculator to find angle B. Angle B is equal to 116.8 degrees. Now to find the other angles, we're going to use the law of sines. So let's write down what we have. Angle B, 116.8 degrees. To find the other angles, we use law of sines. We can still use law of cosines, but as you can see, law of sines is a lot easier and faster. So we want to find angle A, so let's start with sine of angle A over the opposite side is 8 equals to sine of 116.8, that's our angle B, over the opposite side is 19. As you can see, I wrote the law of sines in reverse order, sine of angle on top, the side on the bottom. So we can do it either way, but you have to be consistent. If you start with sine of angle A on top, it has to stay on top. So from here, we solve for sine of angle A, and that is 8 sine of 116.8 over 19, and sine of angle A is approximately 0.3758. Use a calculator, make sure you're in degrees, and angle A is approximately 22.08 degrees. Okay, so it must be acute. Angle A has to be acute because we already have angle B obtuse. How do we find the third angle? That's the easiest. Angle C, we already now the other two angles. So angle C will be 180 minus 22.08 degrees minus 116.8 degrees, and that is 41.12 degrees. So this is the case with the three sides given, which is the easiest case. So example 2, where two sides and including angles are given. Two sides and included angle are given. We call this case side, angle, side. Find the remaining angles and side. So we're going to draw ourselves a picture again and label a triangle. Oops. Okay. Let's try to do this. Oh, much better. Okay, A, B, let's see. Angle ABC. Angle A is given 25 degrees. Angle A is 25 degrees. And side B is 9 meters. And side C is 12 meters. As you can see, the angle is included between the two given sides. So we need to find side A first. That will be the most obvious thing. Side A squared is equal to B squared plus C squared minus 2BC cosine of angle C. This is our law of cosine, and now we substitute. So b squared will be 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of angle 25 degrees. And you type this in your calculator, make sure you're in degrees, and you should get approximately 5.4 for A. So after you square root, that's A squared, A is approximately 5.4 meters. So we found the side A. To find the remaining angles, it's a lot easier if we use the law of sines. So the law of sines, we can write that down as sine of angle B, because we want to find angle B, over opposite side 9 equals, use the given information, and so that is sine of 25 over A, we just found 5.4, and cross multiply. From here, we're going to find sine of angle B, approximately 0.7034, and there are two angles whose sine is 0.7034. So if you use your calculator and do the sine inverse of 0.7034, that will give you the acute angle, 44.7. So I'll call this angle B1, 44.7 degrees, but is there another angle? Is there another angle B2 whose sine is 0.7034? Yes, there is, and that is 180 minus 44.7 degrees, and that is 135.3 degrees. Now, the question is, can that angle exist? Okay, so we can check if angle B2 is 135, that is obtuse angle, but the corresponding side is 9, which is not the biggest side, right? So B2 cannot exist. So we're gonna cross this out. This angle cannot exist because the corresponding side B is 9, which is not the biggest. Okay, so we have so far B1, angle B1 with 44.7 degrees. And now we have to find angle C1, the third angle, which you can find if you subtract from 180, 44.7 degrees, and the given angle, which is 25. So what's left is 110.3 degrees. So this is our obtuse angle, angle C, because angle C, being the biggest angle, facing the longest side, 12. All right, so we are able to solve the triangle with law of cosine. Second case, side angle side. All right, now there is another formula for area of a triangle called Heron's formula. Heron's area formula. And it goes like this. The area of the triangle is square root, long square root, S times S minus A, S minus B, S minus C, where S is the semi-perimeter. I like to use small p instead of S, but I'm following your book notation. So S is the half of the perimeter of the triangle. So this formula is very handy whenever you know all three sides of the triangle. You don't need the height. You can find the area with the three sides. So example, find the area of a triangle with sides A equals 43, B equals 53, and C equals 72. We don't even have to draw the triangle. Let's find semi-perimeter. 1/2, 43 plus 53 plus 72. You add the sides, divide by 2, and you have 84. And then you substitute in the formula. So square root. First we have s, and that is 84. And then 84 minus one of the sides, 43. And then 84 minus 53, 84 minus 72. And you plug this on your calculator, and you should get 1,131.89. And this is the area of a triangle. So we have 3 formulas for area of a triangle so far. So we have the standard formula that you learned from middle school, A equals 1/2 base times height. We have the oblique triangle formula that we learned last time in 3.1 after the law of sines, 1/2 B times C sine of angle A, and there are 2 others you can write down. And we have Heron's formula, which is square root S, S minus A, S minus B, S minus C, where S is semi-perimeter. All right, finally, applications. Applications of law of cosines. Example. Oops. Sorry about the pause. Example, a ship travels 60 meters due east. Then adjust its course northward. Oh. Okay, a ship travels 60 meters due east, then adjust its course northward. After traveling 80 miles in that direction, after traveling 80 miles in that direction, the ship is 139 miles from its point of departure. Describe the bearing from point B to point C. So we have a picture. So a ship is starting from point A. He's going east to point B and then change the direction. It's going northward, goes 80 miles that way for 60 miles here. So, okay, so this distance here from A to C is 139 miles. We need to find the angle B, and then we'll talk about bearing. So to find angle B, we're going to use law of cosines. So cosine of angle B is equal to a squared plus c squared minus b squared over 2ac. We're using the alternative form for the law of cosine. Substitute 80 squared plus 60 squared minus 139 squared over 2 times 80 times 60, and that is approximately negative 0.97. Okay, so now we can find angle B, which is obtuse if we have negative cosine, 166.15 degrees. Okay, that's angle B, but that's not the bearing. So the bearing is the angle from the north-south direction. And so we'll find that if we know this is 90 degrees, then what's left is 76. So this angle over here is 76.15, and that is the bearing. So we say 166.15 minus 90 degrees equals to 76.15. That's the angle from the north-south direction. So we write this as north 76.15 east. And that's the bearing. And that concludes 3.2.